Now we come to the Poisson distribution, and we're going to do number 7 all the way to number 9. So here it says we need to use the mean from the previous example, which was 1. So the expected value of x in the binomial experiment was 1. So our mu needs to be 1. So just like the binomial case, we have a function for the Poisson distribution as well, and that one is given by this expression. This mu is the mean. The mean is always going to be given in these problems. Raised to the power of x times e, which is the exponential constant, which is on your calculator, raised to the power of the minus mean, divided by x factorial. And again, factorial is also on your calculator. Let's go ahead and use mu equals 1, and of course x is equal to 0 from this f of 0. So f of 0 equals 1, which is mu raised to the power of x, which is 0, times e to the minus mu, which is minus 1, divided by x factorial, which is 0 factorial. 1 raised to the power of 0 is always 1, times e to the minus 1 works out to be 0.36788, divided by 0 factorial, which is always 1. And so our final answer is 0.37. We round it to 0.37 at 2 decimal places. Next, we want to find f of 2. So we're going to replace the x with a 2. So this is mu, which remains 1, raised to the power of 2 times e to the power of minus mu, which is minus 1, divided by x factorial, and x is equal to 2. And this is what we have as our expression. So our final answer is 0.184. So we're not going to round to 0.18 this time because this 39 is large enough for us to count it. So we're going to say 0.184. So we round it to 3 decimal places in this case. But in this case, because you're going to need these numbers again for number 9, you might not even want to round it at all. So you want to leave the number just like this, so you have a more accurate final answer. Let's go to number 9. In number 9, we want the probability that x is less than or equal to 2. And we know that this is f of 0 plus f of 1 plus f of 2. Again, x is a discrete random variable. So if it was continuous, then we have to factor every single number in here, but it's discrete, so we only are looking at the integers, the whole numbers, 0, 1, 2. Okay, when we plug this into the Poisson, we get 1 raised to the power of 0, so this is mu raised to the power of x times e to the minus mu divided by x factorial. Same thing for when x is 1 and when x is equal to 2. And what we do a lot if we're doing the Poisson by hand is we factor out this expression here because we see that the e to the minus 1 is being repeated. That's always going to be the case with the Poisson. The expression with e is always repeated for all of these terms. And so we can factor it out. And so we have 1 to the power of 0, which is 1, divided by 0 factorial, which is 1. So 1 over 1 plus 1 over 1 plus 1 over 2, 2 factorial is 2, times e to the minus 1. In this case, we have to only do e to the minus 1 once. And so we're going to have 1 plus 1 plus a half, which is 2.5, times e to the minus 1, which is 0.36788. Our final answer is 0.9197. This is our final answer, so we can round this one to 2 decimal places to get 0.92.